been to current that these aerogel vacuum lighter than air balloons have been done. 2003 would have been the early prototype stage with the Calvin UFO that you saw, a really big craft with really big panels, and the Tic Tac, which we think was formed in a big gas station propane tank.
Interesting. Yeah, they could. That's
put the precursor for the aerogel into the big vacuum or big pressure vessel.
They could
propane
put it inside of a propane tank for the mold.
And you'd have a 44-foot long Tic Tac pop out and put two pumps in it and some electronics, and you've got a lighter than aircraft. And sadly, I don't think their test worked because it was seen by the radar operators and by Fravor, so they went back to the drawing board, and now they use the spheres that are being seen by Ryan Graves and a bunch of other pilots.
So this is explosion forming.
Yeah. So after you explosively form that sphere, you could put aerogel precursor in it, and on the edges of the sphere form a shell, which you could then take out, and that shell would be vacuum proof in both directions and able to resist the pressures that would be put on it. So you have a aerogel sphere however big you want it. If you go up to like 5.75 meters in diameter, it gives you about 100 kilos of lift. So you could theoretically put a person in some small pumps in a 5.5 meter wide aerogel sphere. And if you restricted the accelerations so that he didn't turn into a chunky salsa, theoretically a human could fly around in one of these.
That's fascinating. And the other thing too that you mentioned is, of course, when you're dealing with F equals ma, right? You have force equals mass times acceleration, and these aerogels, of course, have ridiculously lightweight masses. So, the same force applied to an aerogel craft produces, 10 times the acceleration or 100 times the acceleration, because the mass is so low on these things. So they can do these incredible accelerations, right?
So if you have a 44-meter long rounded cylinder like the Tic Tac, the maximum weight that craft can have is about 55 kilograms for all 44 feet long of it. So that's 55 kilograms. An F-18 weighs about 1,400 kilograms. So as you said, if you take F equals ma and rewrite it as F over m equals a, I can exert about 3,000 newtons of force as a human. If I push one of these 55 kilogram aerogel craft, that gives 55 meters per second of acceleration. So after pushing it for 2 seconds, the thing's going 110 meters per second. If I push a 1,400 kilogram F-18, it's going 0.2 meters per second of acceleration. So after 2 seconds, it's going 0.4 meters per second. This is how these craft can do 90-degree turns whenever they want. This is how these craft can shoot up into the atmosphere at incredible speeds.
How do they operate like they're massless? Well, because they are massless, they're bubbles essentially, is what you're saying.
Massless. They're just
not massless, but very close, right? And
they're extremely low mass.
Essentially, the bubble's the shell that you can then get the charge and the energy into that holds it into its structure and the rest of the operations, correct?
And the other fascinating thing is like the video we showed. Sorry, where's the video I showed earlier? I'm gonna go find it and bring it up again.
Yeah, while you're pulling that, my big question is, we need to deal with the inertial mass reduction phenomena, and we also need to deal with the drag or air resistance and eliminate both of those things. So this is another thing that actually is fully viable within the transport mechanism of electron drift through aerogels and graphene layers. However, it does also need to be addressed in the model, because we already have a good mechanism for coupling. We clearly have photonic absorption, and we have a change in its dynamics of how it interacts with the outside atmosphere. It's more than just simple buoyancy, but it also includes buoyancy as part of the respect of its operation. But we aren't really addressing what's happening to the space-time directly around the surface of that material, which is rather interesting, because this is why I want Brian Kelly on here. He's done extensive research and produced many hours of video on that topic. Exactly. If we can get him on here. Brian, come on, man. Can we get you on here?
Where's Brian?
Brian Kelly's in your chat.
You know, Brian, check your
Michael Perone. Hello.
Hi. We got
Hello, everyone.
Perone here, so.
Nice to have a good discussion on this finally. I've been having some great ones with Professor Simon, but it's been a bit one-on-one till this point.
I liked what you did with Professor Simon, and I'm super happy that you're here with Jeremy. But Simon didn't really address you in the full capacity of your research and the depth of it. And I'd like to get into some of the greater details and the, I guess, finer points of the technicals. So we'll see if we can all get in here.
A bit. I have a back injury, so after a while of sitting, my back's going to eventually give out, and I'll have to go. But I'm retired, so I'm more than willing to come on as many times as you guys want to talk about this and answer questions.
You got to bring Professor Simon on too. Thank you so much.
He's interested. He would like to join you at some point in the future too. Definitely.
Yeah. I love his channel, man. He's doing great work, man. And you know, it'd be awesome to do a collab with both you guys. But while we have you here and while we have your attention, I want to ask a couple questions. So this again, right? So this is the aerogel puck here, and you're shining infrared light on this with this heat lamp, and it's causing it to float around and actually provide lift.
I'm not sure that it's infrared light. I think that is just a standard heat lamp.
Yeah, that's a halogen lamp there, and what they've done is, in order to concentrate the light, based on what I'm seeing there, they've got probably a glass lens in front of it, and they're water cooling the outside jacket, because normally you generate a ton of heat. And by water cooling the outside, what they've effectively done is remove the updraft from the heat coming off the edge of the reflector, which means that any lift that's being caused on that thing is directly a result of the interaction of the disk with the outside air, instead of the updraft that would normally be associated with that type of lamp. So the cooling pipes aren't necessary. Is what I'm saying.
Exactly right. That's right. You nailed it, Jeremiah. That's exactly.
You're 100% correct. And in the real world, instead of having a requirement of a heat lamp following the thing around, we are literally just using the sun's energy. If you're going to use this in a power application, you can put a lens to concentrate that sun energy on whatever aerogel lift power generation device that you want. There's one of my designs. Sorry, I'm not the greatest illustrator or technical designer, but I wanted to get these theories at least out to others so that if they are, maybe they can refine my designs and make a better one.
Bless
we're not worried about the quality of your drawings.
With this, though. Bless your soul for open sourcing this knowledge and technology, because that's what needs to happen in these communities and just in society in general.
Now, I want to bring something back too. A really important point in terms of removing the air friction. Okay, so there are some old NASA docs, and one of those things was completely eliminating air friction or increasing it by causing the magnetic braking effect. And the simplicity of it was, if you place one pole of a magnet in the direction of motion, so you have a disk magnet and say you face the flat face in the direction of motion, it will actually slow down that magnet because it'll entrain and grab onto, through eddy currents induced in the free ionic charges in the air, a slowing. But you can also increase the velocity and remove air friction by giving an ideal pathway for the air to curve around. And it's interesting because graphene in particular, graphene, and also borphine all exhibit this property. at the surface, there are intense magnetic fields. So they may not extend out very far, but they are at least far enough to encompass the molecules of air directly in front of this thing. So it could theoretically be done by the nature of the material itself. I consider graphene and graphene to be a metamaterial, and especially aerogels to be a metamaterial. They could perform that same function of this coiled wound electromagnet directly in the material itself and completely eliminate air drag.
Had you seen the research that we've released on the magnesium bismuth composite aerogel?
Yeah, we've also done hundreds of hours of our own research and very deep exploratory calls, just like this one, about specifically that topic, the molten Howe layered structured material.
Yeah. So we believe that that is currently being used as the exterior shell and the battery at the same time of the CCP's version of this drone, because they stole a bunch of the research from DOE in about 2011 and started their own
China
internal
and
R&D.
the US. Thank
Yes. CCP, I'm willing to go out and say, has slightly surpassed the US in research because the US is keeping this research in secret and silent. They've got everyone siloed. No one knows the full design of the craft. They're all working on one thing.
Compartmentalized it and convinced half of the science group working on it that the other half
That it
of it
doesn't
doesn't
exist.
exist and isn't possible. Thus, they've reached this impossibility block just because of the bureaucracy and idiocracy of the system.
Yeah, that is exactly what has gone on, and we can see it in how the research around these materials has progressed since 2011.
Yeah,
So
wasn't it you that mentioned the second that MIT released their findings on the in-depth research, just shortly after, within months, that China suddenly started a massive effort to investigate and develop this material?
Yeah, so when Dr. Steven Steiner did the breakthrough aeroloi announcement, within about 2 months, we have research papers coming out of China that link to the Chinese research and development program budget. So we have their budget. It started in 2011, and they have all of their best scientists working on these materials and the craft design, whereas we have a single physicist, a single chemist, and maybe some part of Lockheed. This is why we have fallen behind.
I'm sorry to interject, but with what you just stated, and are you aware of the Ashton Forbes MH370 whole case now, and these are essentially the Tic Tacs and like this technology? Was it essentially that same technology then used to take those the engineers on that MH370 plane? And
well, this is interesting.
all involved? Like this is almost too much, or like
This is an interesting point because if you have graphene like spheres, you combine that with the Kevin Kramer Lake Marabou technology that was covered in the Drives article of 2020, Brett Tingley, this article here. Just imagine this dart being, a graphene aerogel dart instead, and you're propelling it around with lasers, the same way that they have these technologies described. I don't know if you've seen if you go to patents, find the Kevin Kramer patent. That one will show you where they literally take this one right here. It shows an airplane beaming lasers onto a plane wing so they can take control of the plane wing by they can move that surface by heating it with lasers from a distance. So just imagine instead of a heavy aluminum plane wing, you have aerogel instead. It's the same kind of concept, man. You could fly those things around with this technology,
but exponentially more realistic and feasible.
Yeah, to Jeremy's point, this has actually been done since about the 60s. In Shirley's Bay, Canada, they had a research station that used microwaves to keep a satellite up in the air, in the atmosphere, not out in space, for I think it was something like 180 days. It was just kept up by hitting it with pulsed microwave energy. So that's
Because
definitely
it's
something that
convenient.
exists. I'm not sure if it's the most efficient way to do these craft. As we can see, just by balancing their pressure, they can stay up in the air forever, and they're constantly harvesting energy to their internal batteries from the sun. So they've got enough power to power those pumps and stay up in the air forever without lasers. So we like to provide the
Be
simplest
efficient,
explanation.
obviously, yeah.
If lasers are used, we're open to that, and we'd love to look at the patents and research around it too.
Yeah.
I'll also address the MH370 Ashton Forbes thing. I have not done as much research as him on that subject, so these are only my views. I personally believe that both videos are likely fake. The IR video has an inconsistency where two contrails in IR pass over each other. At that point, the coloration of the two contrails increases. So it goes from a lower temperatured color blue to a higher temperature colored green when they pass over each other, which an IR camera would not show. When you stack two sources of heat on IR, it will show the higher of the heat values, which would be one of the two colors of blue. Instead, this fake shows that when they go over, they add to each other and become a green, a hotter heat source. So simply moving two heat sources over each other in an overlapped fashion does not cause them to become hotter. I believe that conclusively debunks the IR MH370 video, and I definitely saw that post by Mick West yesterday. I'd like to see some
Oh, there's a
explanation
new
of
one. I haven't
why the
seen it yet, so I
clouds.
guess I'm missing on that.
Yeah, he has provided a image that shows a wider section of clouds than the video does, and they match up very well.
Oh, really? Okay, I was unaware of
So
that.
it's
Huh.
possible that that sourced
The
cloud
drama
image that Mick
continues,
has
but maybe it
provided
is
was
debunked. Yeah.
used to make a fake satellite video, and then they also produced a fake IR video as a form of corroboration. Just my views. I haven't done as much research.
So
as that.
just to add to that, then, so if it is fake and you're out there and you're sitting on this evidence that it's fake, supposedly there's $150,000 bounty, 100 grand supposedly by Kim.com.
I don't have the original videos, so
Yeah.
Right?
Kim.com
Like
isn't going to give me any money,
out there,
and
whoever made it.
I'm retired. I don't want money.
Give me money.
I'm not in this for the grift. I'm just here to give free information.
Oh, for
to
sure.
people.
I'm speaking to the public in general, right? Like anybody out there, like if you do have it, cash in while you can if it's fake, right?
Yeah, I think according to Kim.com, I think they would need the actual original source files or tapes that it was generated from.
Yeah. Oh, for sure. I would require that
So
too. If I'm giving out
someone can do
100K,
that.
but
Yeah,
right?
I'm
Okay.
just giving
Yeah.
my view that I think the two videos are both provably fake.
I'm not married to the videos either way. I'm definitely think that there's more to MH370. The science. It's just
My
weird that they
personal
have all
suspicion
this.
is it was a conventional hijacking, and the plane ended up at Diego Garcia. It's obvious. It's the direction that
I think I agree with you. Just
Yeah.
on at the end, it ended up at Diego Garcia, and thank you for
So
stating
why
that.
couldn't that just
And
be a
not
conventional
Brian Kelly.
hijacking that is covered with two fake videos?
Yeah.
They had enough gas
exactly.
in the plane to get to Diego Garcia. At the time Kate T saw this plane where it was supposed to have made a turn, it could have just continued to head straight and it would have ended up at Diego Garcia. I suspect that these two videos were produced to cover that fact up, that the plane just continued naturally and landed there.
I love how it was a totally off-the-shoot topic, but you were absolutely able to engage with it
Right.
and give a good response. I appreciate that. We do have Brian Kelly now, so if you wanted to get into the good deets of inertial mass reduction, and how these materials can
Yeah.
utilize space
I
time
mean, this isn't
engineering
really
to their advantage.
inertial mass production. This is just pretty conventional technology.
Yeah, this is
Right.
extremely low weight craft.
Yeah.
But there's another advantage to that material that goes beyond just minimizing the weight and creating structurally strong materials.
Well, before we go off on another tangent there, I'm interested to talk about the implications of lighter than air aerogel drones. So first off, you could potentially make an ionocraft that could leave Earth's atmosphere, right? So you could
Yep.
have a vacuum balloon, perhaps with some supercapacitor arrangement for fuel, and then just put an ion engine on that. And if you can get up to the mesosphere, you're starting to have enough a lower amount of drag that you can probably pull out of the atmosphere at that point.
Yeah, so you raise a very interesting point, Michael. Thank you. In our original research document, we actually proposed a way that any of these craft could get into outer space. If you think about it, the aerogel craft, even just a sphere, and you bring it down to about sea level, if you explosively decompress all of the pressure from the inside of that craft, it's going to have a vacuum inside and be as light in comparison to the pressure at sea level as you can. It's going to give a lot of upward acceleration to it. If you calculate the vector correctly, that thing's going to shoot just straight out the top of the atmosphere.
It wouldn't just get up to the stratosphere or something? Or
It's going to attempt to balance with the weight of the craft, which at that point is just the weight of the shell because it's got a vacuum inside of it. So
but that's
it may balance somewhere in the stratosphere. It may carry acceleration further out.
I would love to see like a demonstration of it because you could do calculations all day, but one good test is worth 1,000 expert opinions.
I mean, you get a lot of vertical that way, but you need horizontal velocity to get out of the atmosphere or to get into space.
But you're saying that if you had one of these,
jump into space for a minute, but then you'll just come back down. It's not in orbit.
Correct. You'd need to achieve some kind of propulsion once you're in orbit. So my follow-up question to you was going to be, what's the lightest weight ion thrust that you guys have encountered? Like, can you miniaturize this in any way so that there's a
Well, I've got it miniaturized. I have a power supply that weighs 11 grams that can produce 40 watts. And
I've got the power supply covered for you.
So.
I've got the power supply covered for you. The craft itself is a battery. The shell stores charge and can power internal devices.
Yeah.
So
I've got the micro miniaturized conversion covered too. So together,
the battery you're talking about in the shell is probably going to be several volts, up to like 100 volts or something like that. What Jeremiah is talking about is something to take that low voltage DC into a high voltage, either DC or AC, that you can use in an ion lift device.
Well,
it's interesting you say that because South Korea right now is.
Point is, you could just get a CubeSat ion thruster. Like for CubeSats, they're like 10 centimeter by 10 centimeter by 10 centimeter, and you can get an ion thruster that's a couple grams even.
Hey,
Michael, that's a thruster that uses xenon gas.
Oh, there's a couple types. There's the one that uses xenon gas. There's one that uses lithium metal. There's one that uses magnesium metal.
Right, but they're expelling something out the back. They're essentially ion rockets.
You can get to space this way. You don't need a rocket this way.
They are rockets.
What?
An ion gun in that sense
chemical rocket.
is a rocket.
You don't need a chemical rocket, is what I'm saying.
It's still a rocket, though. I have to agree.
It's still using up
fuel. You need to be chunking stuff out the back end in order to move forward.
This is all conventional stuff. This isn't like anti-gravity, really. This is buoyancy in the atmosphere, which is more valuable than people suspect, perhaps.
I have to interject. Buoyancy is the key part of gravity, though.
Remember the Sonora Aero Club, Jeremy? Like if people back in the late 1800s, early 1900s had like personal hydrogen airships, in principle, they could have gotten into space with those. if they had like some
Yes,
I don't know.
100%, and that's why I suspect we see so many of these cylindrical UFOs that they speak of, and why Gary McKinnon specifically states that's what he saw scrubbed out of the NASA photos that he found when he hacked in.
So I think
Yeah,
that the
it's they're
problem
more
that
like
the
a blimp
aero
really than
clubs
a
would have
UFO.
had in the 1800s is that once they encounter space, they've got the vacuum and the pressure of space to deal with. The advantage of the aerogel craft is that aerogel naturally, as a material, resists vacuum in both directions. So if you send one of these craft into space, whatever's inside the craft isn't subjected to the vacuum of space.
Yes,
So
you're going to
it'll still
enhance
leak, right?
buoyancy.
It'll still leak
Sorry, a
though.
couple questions
Well,
overlapped there.
my bad. Yeah. The aerogel resists it, but it's still leaky though, right?
No, it's not. Gas simply cannot pass through an aerogel. The holes in the aerogel material, the voids, are simply too small for gas phase heat conduction to occur. So
But Knudsen pumps still work or whatever they are.
yes, you can put
Question,
Knudsen
real quick.
pumps. We believe that zeolite pumps are actually the ones that are used in these craft as the pumps. So that pump is the one that can change the pressure on the internal vacuum.
Before we jump on, can we give Kelly the mic for a second? He's been patiently waiting.
Okay.
Yeah, I have one question first before we go there. These silica-based aerogels were invented when? Like these were like go back to like 1900s, right? Like early
1931.
1930s. Yeah, so 1931. But
And
those are
not
very
just
fragile.
silica.
Those will break
Yeah,
apart.
not just, yeah, correct. But in Kistler's paper from Nature in 1930, he actually describes that they didn't just make silica aerogels at that time. He describes a paragraph long of aerogel composites that they had in 1931. So if
And
you
were
take
any of
his,
those strong enough, rigid structurally to hold vacuum to make one of these?
I'm not sure that they had discovered the polymerization second stage of the alloy process that's currently used. So in about 2011, Dr. Steven Steiner released a process to the world that described coating the finished aerogel's structure with a polymerization. So they rigidify the entire structure after it has been made into an aerogel. I think that step would be required to resist a vacuum. I think that the earlier craft are just using the alloy or the aerogel composites because they are lightweight. So if you had a helium balloon craft, you would want all of your components to be made out of the lightest weight stuff. So instead of using an aluminum strut, you would use an aluminum aerogel strut. It's got similar rigidity properties, but it is more lightweight, so you can put more stuff onto the same
Now you got
amount
me
of
really
helium.
excited. Aluminum aerogel strut. Where can I get a sample of that?
You can make one yourself.
No, I don't
Yes,
want to make one. I
yes,
want
you
one
can,
shipped,
Mark.
and I
I've
want it
been
here by the
making it. I
weekend.
can send you some. I swear, it is so easy through
Mark, you
electrolysis.
can
Bernie,
make this stuff in your
please
oven
send
if
me
you
some.
want.
I would like it here by next week. I want to run that through the Alzheimer's experiment. It needs really to be really small, but
Yeah,
I would
I will
love
give you
to
4
have some
different types.
aluminum
Careful with that. It's
aerogel.
going to be super flammable.
Mark, this
Some
is
of them
an
are, yeah.
alloy that is not able to be broken by my hands. Like,
Uh,
I'm bending it slightly, putting as much pressure on it
Does
as
it
I
have
can.
aluminum in it?
I'd have to look up the specifics of that. It's
I
Airloy
want
X116.
aluminum aerogel to run through my, because one of the problems we're running through here is something called the skin depth, and we're not able to get the RF to penetrate the aluminum because the samples we have are too thick. If we had an aluminum aerogel, that would solve that problem possibly. Really, Bernie, if
talk
you
to
have
me
any of that
offline
available, send it over right away, and I will pay for the shipping. Okay?
Mark, talk to me after. This is Josh, and I'll show you where you can get some.
Okay. Or you can just drop a link in the private chat, and I'll order some right now. I'll see when they can ship it.
Yeah. On StreamYard, there's a not public little section called private chat that's on the right side of your window, and you can drop links there.
I will send you my
StreamYard's running
clear
on my phone.
aluminum
I'm really
gel
sorry.
stuff and the foam.
Oh,
There's
never mind.
also foam ones as well. I'll send Mark.
Okay, yeah,
Right.
I'm only really interested in the aluminum, but if you want to
Yeah,
send anything else
they're
over.
both aluminum. This is straight aluminum gel, and then I've got straight aluminum foam as well that I can send you both to try working with, playing with. See what
Yes, please do. Are these aluminum oxides? Are they already oxidized?
I'd say they're not oxidized because they haven't turned blue. They're straight clear, and the white ones, where anytime it oxidizes, it seems to like always turn the blue transparent or teal or blue.
Well,
or then
if it isn't
does
oxidized, it should be conductive. Is it conductive?
I haven't tested it. I've just kept it in.
I mean,
kept it in
alumina or aluminum
in-
oxide, like
in-
crucibles, those are aluminum oxides.
I'll
It
send
appears
you
to
like
be, from what
6
I've
or
seen
7
from
different
Bernie's
aluminum.
samples, like Bernie has showed us many times. I've had him shine light through it and all kinds of stuff. It to me looks like a charged, unbalanced aluminum salt gel. It's a very strange material, and when it hardens up,
But
It,
have
this
I
never
shown
made
you the foam ones though? The actual foam that comes off of the metals.
I just want to run it through the EPR experiment because that will solve our skin depth issue.
penetration on those materials that Bernie accidentally generated should be extremely good for what you're doing.
Right, we're at 9.5 gigahertz, and skin depth on pure aluminum is like nothing. Like it goes
Once
down.
you get to the water component, I'm guessing you'll have complete penetration, no problem.
Yeah, that would make sense why they would use it on a craft then.
Well, we got Brian and Joshua together, though. Why don't we talk about the light pumping into the aerogels?
That's what I'm doing also, dude. I have literally have a laser. I have a laser hair removal device over here that we're going to be pumping light into it in order to create these triplet state electrons, which is supposed to increase the effects of DNO by 250,000 times.
That pulse laser might be overkill. You might need to.
I can
honestly,
tune it down.
It
It has a controller on it.
is it a UV laser? Anyway, whatever.
It's not. It's wide spectrum. It's IPL actually. It's not really a laser.
Okay,
it's
so you
intense
want a
light.
UV laser. You just want a low energy normal UV laser pointer.
Damn it! I just sent mine to Todd. I had one. I had a nitrogen laser here, and I sent it to Todd.
Oh man, I would have bought that.
Dang.
It wasn't for sale. It came from Canada with what's his name with the Hathaway stuff.
Canada with love.
Yeah, maybe I should ask Todd for it to get it back. So you really think I need it? I think it's nitrogen is what 1064 nanometers.
There's UV laser.
No, that would be yttrium doped vanadate.
Anyway, Brian was going to present or talk.
Yes, I wanted to say that I thought I want to thank Josh for showing that heat lamp experiment. I think that's going to be in my opinion, that's the key takeaway here today. Is you just saw on the Alien Scientist channel a piece of mass. I forget what it was. Anyway, levitating.
Yeah, it's a graphene aerogel.
All right, graphene aerogel.
Carbon nanotube, I think, but yeah, close enough.
Yeah, close enough. Graphene aerogel. You're in the right ballpark. You're on the right track. Those are the first metamaterial. This is it right here. See that?
Yeah.
That thing, that's your gimbal. That's your go fast. That's your tic tac. That's your triangle. That's all that stuff. That's all that is. You take that principle that you're looking at right there and optimize that.
Brian, it is free energy too.
And it's free light. It comes from the flipping
You
sun.
can put it on a windmill, heat up one side of the windmill with the sun, and that windmill will keep going as long as the sun keeps hitting one side and the other is in shade.
Yes, it is.
Ultimately, with these
can't let it out. Hey.
And ultimately,
It's
with
free
these
energy, it kills it kills oil. There's not going to be wars over oil anymore once this gets adopted.
Yeah, yeah, right.
Oh my God!
doesn't
Everybody's
require-
gonna have abundance, and we can stop killing each other. How
much free?
horrible!
How
It
much
doesn't
free do you
require
freaking need?
germanium like normal solar
It-
panels require germanium, which is
This is
like
awesome.
that's more expensive than oil.
But you have to work for it. You have to find a way to capture it more and more efficiently, like I'm looking at right on this screen.
Yeah.
You don't need to try these far out ways. First, you try the easy way. You're looking right at it. Do I need to get my mirrors and balloons out from Dollar Tree? It's the same thing.
I just sent Jeremy my most refined power design, so I'd really appreciate if you guys gave a look at it, since a lot of you are
There we
better
go.
engineers
Please
and
forward that to
physicists
me, Jeremy.
than I
I
am.
gotta see it. Please
What's
forward
the
that to me.
efficiency? What's the efficiency on that? Like, is it
I need
complicated
someone to
somehow?
work that out, because I'm a mathematician and investigative journalist. I have a little bit of a physics background, enough to understand the concepts and talk to you guys about them, but I can't work out the efficiencies of this directly. That's not my area of expertise. So I don't know, if Jeremy can bring up the diagram, you can look at my poor Photoshop skills and make
Honestly, we're not
comments.
worried about efficiency. And the thing is, efficiency sort of breaks down when you're trying to consider equilibrium forces or a conservation of energy and momentum when you inhibit a nonlinear space-time. So all these things, they're sort of tertiary. What we really care about is what results we can get in the lab versus how much losses that we end up getting through optics or other means to provide sufficient photonic energy stimulus to these samples.
Sure.
But
I
ultimately,
sent
it'll
the
run on
diagram to your Twitter, Jeremy.
ultimately it'll run on the cold terahertz temperature of space. You make the material fit the environment. That material we're looking at there, that fits in with heat and light, which is where we live, which is why balloons work here. But if you take a helium out to outer space, it might freeze up. So you're going to have to use something that works there. Is it bismuth, whatever it is? Yeah, somewhere. Somewhere you're going. Everywhere you go, you're going to find some light that you conform to. It's not easy. You have to do a little work. You get the free energy, but first you have to do the work. First, you have to get the concept. Then you have to start with the basics, like is happening here now, I hope. And
Yeah.
you go from there. And this is foolproof. You are looking at it.
I agree with you. Like, I've had this information out to the public now since November 15th, and we haven't had this debunked or disproven. A couple people
It'll
think
never
that there's
happen.
Yeah,
Yeah.
a couple people think that there's better ways that it could do its propulsion in a couple directions. A couple people think that it might not have been the Tic Tac, but the core basis of our claim is that we have the material now that can make an
Yes.
aerogel vacuum balloon, and it can
Yes.
also lead to free energy. So
Yes. It
I
uses
think that
free energy.
yeah, it
Yeah.
uses the energy of the sun, which I don't
Josh.
know. Do we really care if we're losing photons from the sun due to efficiency?
No.
We're
We
turning
do not
them into
care at all
power
because we're not paying
Yeah.
for it. Who cares
You're
what
with
reusing them.
super cheap carbon. Like, this entire thing can be made out of a little bit of carbon and maybe some steel for the rotor stator on the generator. Like, I'm gonna make one myself, and I'm not the
you're gonna need
greatest
a lot of
engineer.
matter.
If I can make power out of it, then everyone can, and we can do it better as an open
Not trivial to
society
make
talking
nanotubes
about it.
either, though. But I have another question. What was it? The uh, for vacuum airships, is it optimal to? Is there an optimal composition that's non-zero, not total vacuum, or is it more favorable for a vacuum airship to be complete vacuum? Because you can, if you have a partial vacuum, you can make a partial vacuum airship. Then you need less material to enclose it because it has less pressure difference.
Correct. So what we're actually proposing here are that these aerogel vacuum lighter than air craft, the balloon drones, have a modifiable internal vacuum chamber. So by using two pumps, you can pump air into the chamber to increase its pressure, and you can pump air out of the chamber to decrease its pressure. And by using that effect, you can modify the height in the air column of the drone itself just with minor power to a zeolite pump, a Knudsen pump.
I could watch this video 1,000 times, but Joshua, I believe you have also the links before they were pulled down from that Nature article of the sunlight and lens levitation as well. Is that something that you have access to and you can send a link for?
Yeah, I sent the link to Jeremy on Twitter, so in his DMs, he has the sunlight power diagram.
And also the video. There was a
Maybe
video
you can pull
associated
up.
where they've got inside of an enclosed container, looks like about a 7-inch diameter by 7-inch tall vase upside down, and they've got that piece sitting on the ground, and they use what looks like a 6.5-inch diameter glass lens, magnifying glass, to focus on that disc, and it works there.
I just
It'll
sent
work
that
with a
over to
Walmart
you.
mirror.
I just sent that over to you too, Jeremy, if you're able to pull either of those up.
So with the partial vacuum airships, then what I was kind of asking is there an optimal point that's non-zero vacuum, or do you just want to get as much vacuum as you can and deal with the engineering consequences of that?
Yeah, correct.
I don't know.
You want as much of the craft's weight to be used by the pressure chamber so that you can get as much acceleration as possible. So the size of the vacuum chamber determines how fast you can accelerate in the up and down direction, because that's the amount of air you can pump out. That's the way that you lower the pressure of the craft.
But you're going to be limited with that as opposed to a pure aerogel where you can keep jacking it up and pumping it up and hitting it harder and harder and harder.
What I'm asking is what's the most buoyancy that you can get?
With what?
Depends how big you build the craft.
Right. So I mean,
if-
it scales with volume, of course, but is there an optimal point? In terms of the graph of this thing, is there some optimal point in between normal air pressure and vacuum, which has better lifting properties if you then can reduce the amount of mechanical material required to hold the vacuum out?
Well, you'd want it adjustable and as possible. And
Yeah.
yeah, so the point is that's going to be limited. That's good. That's useful. That'll be good in atmospheres like Earth. There's a guy on Twitter, I think he's still there. His handle is vacuum graphene 3D graphene vacuum to space or something. This guy's got drawings, he's got patents, he's got all this and that. He's been at this for years just with the graphene and stuff. I haven't seen him on Twitter for a while, but again, you're going to be limited there. If you get the light pumping involved, which aerogel does very naturally and stupidly, it's a good start, but it's not as controlled as it could be and will be with metamaterials, where your gas isn't just stuck in there. It's literally attached to the graphene or other metamaterial or other substrate. It's you take the atom and you stick it right on the mass, the atom that pumps light, like hydrogen and graphene is the simplest example.
Well, if you don't have to go to full vacuum, then so basically, if you can get more buoyancy and not have to go to full vacuum, then you never have to pump past that amount of vacuum.
Yeah, you might not.
So then
You know,
save energy, and you have
ideally
something
you
that can
don't.
have more buoyancy.
Yeah, so ideally you don't even use the vacuum but you start with it. And you might use it some places. You might use it for a floating buoy, like a sphere going around the Earth, snooping on the Earthlings. Just floats. It's dumb. It doesn't really have to go up, down. It's not that high tech.
That's
If you
also
want
not
to,
really what I'm saying.
okay.
So how do you optimize this? Is what I'm saying. So if you
With the meta,
if you reduce the mechanical if you reduce the amount of aerogel in a thinner shell, then in principle that's most of the weight. So you can go to a lighter. You can get more buoyancy per volume potentially. Maybe I mean I don't know the equation for this, so that's why I'm asking.
well,
But you can. Is there an optimal point where you reduce the amount of aerogel to an extent, and then you reduce the hardness of the vacuum to an extent, and then you get more buoyancy total? Because
yes.
then I mean
But the
maybe
answer to reducing, I would say my answer is, yeah, reduce the vacuum to zero. It
Yeah,
works. But
yeah.
why, I got a bicycle and a car. Which am I going to
well,
use?
it's suboptimal is all I'm saying potentially. I mean maybe it has better structural integrity, I guess.
Yeah, yeah. But it's a good analog here for we're doing alien science here, not 1670
Well, this is human science.
Atlanta.
Deterzi, his vacuum design
Yeah,
from
right. Yeah,
1670. Yeah.
I saw your cartoon there or your drawing. Yeah, I'm
Thank
a
you.
big fan of that guy. That is the father of aeronautics, not the Wright brothers, not the rocket scientists, not
I'd
the
argue it goes back to Aristotle because Deterzi credits Aristotle for his
yes,
design.
because he said what? Heat goes up. That's a simple thing.
Form is the essence of function, or something like that.
Add
The ancient Greeks believed in metamaterials, but they couldn't make them at the time.
when you add heat to water,
Well,
it becomes
actually,
air.
sorry, I have to interject. The ancient Greeks actually were finding more and more evidence that they were quite adept in the metamaterials and the nanomaterials, like the nano cup with the gold that it's both green and red when the light shines through. They somehow fuse the nano gold into the crystal itself. And then there's Roman concrete as well that we can it's still lasting thousands of years later. We can't even reproduce that sort of quality today. So that also with the Romans and what you're saying with the magnifying glass, it just brings the images that we see of the Romans back in the day with their giant mirrors and stuff like that. And I can't help but then tie in sea foam. And is sea foam essentially a type of this aerogel and this ion metamaterials, and why we see all the craft, these tic tacs coming out of the oceans?
May I
one
add
of the-
something before we
In the
jump
world
onto
with
that
that
too far?
sentence.
Because I wanted to add a really important point here, and it has to do, going back to Aristotle and what Brian Kelly said, if we consider that heat is a form of energy and energy density is directly correlated to mass energy equivalence, then we can calculate or inherently derive through the equations and through the allegorical experimental data that increasing the thermodynamic motion of a given sample without increasing its volume changes its mass energy equivalence and its inertial it's an inertial mass ratio. So
Aristotle came right out and said if you add fire to water, you get air. Now that might sound stupid to us now, 2,000 years later, or how many thousand years later, but what he's saying is
Well, plasma
a thing
to
that's
liquid
heavier than air, a
equals,
thing that's
yeah.
heavier than air, water is heavier than air generally, until you add fire, aka
Phase
photonic
reaction
energy.
science.
I gotta
You're
support what you're
absolutely
saying,
right.
Brian.
It's phase calculations, and the ancient alchemists understood this.
I want
And
to
that when
say
they had,
something to you, Brian.
hold on, I just have to put this out there for all the engineers and physicists and chemists out there for the understanding of ancient alchemy. There's the four elements of fire, water, earth,
Yes.
and air. But really, that's just the four states of matter being plasma, fire, air, gas,
Yeah,
liquid,
but these
water, and
fundamental,
solid. And it's the states of elements in those phases.
Don't forget,
right,
Bernie, there's the fifth element. The fifth element has to do
Well,
with
the
the energy
fifth
density.
element is the element in the
multifaceted.
periodic
Boron?
table of elements itself. Like that's what it is. It's like plus the element, the fifth element, but it's like it's applying those four states of matter to the elements,
If you
and
take
then
any of the
their
four states of matter
calculations.
and you apply the energy density to any of the four states of matter, you will derive the fifth element.
Oh,
That's
that is
why.
a key part of it, and that's why there was sacred geometry was so key in all their calculations, because instead of having to do like a million different decimal mathematical calculations when you're working with just the geometries of the shapes of the crystals of the formations of matter in itself, it's just a completely different set of making something exponentially easier to understand and work with than breaking it into shattering it into a billion different fractals essentially.
And to specify, this fifth element that I'm referring to is not an element like we think about on the periodic table. The fifth element is a reference to a state change in any of the other four elements applied to physical matter. We end up with the derivative, and it allows us to do really fantastic things with common materials.
So are you talking about the point of criticality then? Because that's very key to the production of these materials.
As long as we're not talking about the critical point of phase transition between the four conventional phases, which is your solid, liquid, gas, and plasma, what we're talking about here is actually a change in the space-time refractive index in relationship to the mass energy density of the physical material that it's composed of.
Yeah, vacuum has a phase change too, and that's what the weak force is and the strong force eventually after that. Those are vacuum phase changes.
So do you guys want to dig into the power generation aspects of this? I know we've
I'd
talked
love
about
to,
a lot
please.
of the UFO aspect and how propulsion would work, but I think that the thing that's going to solve climate change is the power generation aspect combined with what Jeremy was talking about 2 nights ago. One of your guests mentioned the idea of raising solar umbrellas into orbit, and that if you could raise enough shades into orbit, it would lower the amount of sunlight that's actually heating the Earth. And if we are being heated up, that would be a potential way to slow it down. Now, if you
Oh yeah,
take
that would
these,
actually make sense. Yeah,
if you take
Oh
these
yeah,
aerogel
aerogel shades
craft
would be great.
That is
and use
actually
them
genius right
to
there,
raise
because
a shade into the air, you can raise the shade with an aerogel craft, have the craft raise it into a geostationary orbit of some sort, and then the craft just comes back down and you reuse it to lift the next one and the next one, and you're not using a solid fuel rocket to raise each shade into orbit. You're using a
Well, wait a minute.
reusable.
Why do
But
you even need?
Joshua, you're stating though that the
Bernie,
issue is that we're getting more solar radiation we have to block out. It's not necessarily the
We're not
CO2
getting
that's
more
negative.
solar radiation.
No?
It's just that the solar radiation is affecting us more because the carbon in the atmosphere is trapping more of that heat. So
You just
one
showed
way,
us how to make
And the methane
cars
By
and
the
calculus.
way,
trucks
Joshua, that's
lighter.
exactly what Brian said. Brian literally said exactly this thing, and he's got videos on his channel, which you should check out, talking about this. Go ahead.
Well,
So
if
I
you're
think
worried
that
about
Josh,
if you're worried about
you don't even
climate
need to.
change, if you're worried about climate change and you want to cut carbon, just imagine if your car weighed 20% less and the truck that brought your groceries. How's that work for inflation? Is that good?
if your bus
Everything goes
was an
down.
aerogel vacuum that floated through the air with a pump and used
That's
the
what brought your
sunlight to power
bananas.
itself, instead of having buses that are pumping out burnt gasoline byproducts. I also
Yes.
think that since we're currently running a lot of our power grid off of burnt coal and burnt power, we could switch to using more solar, more hydroelectric, more tidal as we transition over to an aerogel lift power system. So as you're building
I don't
out
understand
the
how
next-
this scales, though.
if you could bring up my diagram, I'll try to explain how that scales out to large-scale power.
Yes, please actually, like, let's just do this segment of let you show us like a feasible, like reproducible energy generation. Like, we need the more of these ideas out there. And
I just sent
yeah,
you a
We're
new
not there
picture,
yet to show
Jeremy,
it.
if you can
We're
bring
not
that
there
up.
yet because we
What
haven't
is-
built it. We're discussing it
what's
now.
that
So
you're holding?
we can build it.
Oh, hold on. I'm
Mike,
muting him.
you're muted.
Michael, yeah, you're muted.
It's just a chunk of graphite. I couldn't find a pencil, so just using this to get some graphite on the inside of this vacuum pump.
It's a giant's pencil. I love.
Giant pencil.
I want to wrap copper around it and then aluminum and then connect it to electricity and
No, that's not. It's not a chunk. It's not a ferrite core. So, what was I saying? So, I mean, you don't even have to get shades into orbit. You could just use these aerogel balloons as shades in principle.
Yeah, you can do
Well,
that
and as
too.
the Earth
Yeah,
turned
honestly, it would be
every
more
day, as you
serviceable.
hit the
You would-
sun, they would
yeah.
rise back up, right? They'd be like self-powered, where they like
Well, the thing
inflate.
is,
Yeah, I mean, if they just
Yeah,
stay there,
it's
it's
like
better.
night
It's better than all those like deep state ghouls who are just trying to make put like dust in the atmosphere to reduce the solar irradiance. Like, and also like if you get the balloons up high enough, you can get them where they're actually emitting infrared to space, so they're cooling the planet down actively.
yeah.
Yeah.
I wanted to mention
So-
too, in relation to borylphene and graphene, what we noticed is that based on the studies of borylphene, what will happen is you'll get thermal absorption photonically from the faces or the wide surface area of the front of that lattice. But what it'll actually do is reconvert any Brownian motion or oscillations because of the coherency of its lattice structure into the edges. And so heat will go in from the surface. It will then be diverted 90 degrees orthogonally to the edges, which means that your equal and opposite reaction forces are displaced. And this gives us a significant advantage in terms of the total lift efficiency per unit input of joule energy over any given area volume. So it seems to really make sense because we know these materials, they can turn the direction of any input field 90 degrees. And when they're 90 degrees, they can't interact directly with the source of that photonic stimulation.
Those meta surfaces are going to be a whole field.
Absolutely. They're the future of this research.
That's it. When you start controlling that, the light matter interaction, that's the key.
I think it has
climate
been a
change-
field for 93 years now. It's just been hidden from every scientist that wasn't determined to be a government insider.
And guys, if you're not subscribed to Brian Kelly on YouTube, you should go check out his posts. He's got tons of papers on metamaterials and graphene, amidst some great political commentary as well. So definitely,
Maybe too much. Yeah.
yeah. Stick
There
more
can't
with
be
this.
too much, Brian. Democracy's in a sad state now, and open discussion is what's going to save it.
Well, it was the free speech on Twitter that got my goat. I couldn't hack it anymore. And then this was before Elon Musk, but plus I'm
agree
retired,
with
so
you.
who cares what I say?
Oh my God, I agree with that comment so entirely. Open discussion is what will save it. Man, that couldn't have been said better.
Oh, and Elon Musk is a hero to the First Amendment.
100%.
Hey, there is no way that my concepts would have been allowed to stay on any other social media platform. As soon as anyone in the government saw it, I started getting attacks. I've been attacked by the CCP for pointing out that they have hidden drones. I've been attacked by what I believe to be US government agents that think that this is a nuclear secret. It's not. It doesn't emit any energy or any power on its own. It's just a
It's all
bubble
like cold
of polyimide
fusion
aerogel.
more, right? It's more of like a cold fusion style or like endothermic-ish.
Related, but
it
not
is just
direct.
using metamaterials
Oh,
and
just-
solar power.
Just the sun. It's all about the sun, using the photons of the sun, the center of
100%.
it.
Yeah.
It's all
The sun
pretty
and the
That's all it
stars.
is.
It's all
The
pretty-
sun, the
all
stars. and space itself, which is just packed with cold photons. Those are photons that are just as usable as heat or anything else.
So I've got a
Just
question
blow
in
away.
regards to this aerogel, a charged bubble of it essentially, and like, is it why? Like, did the Simpsons like see the future again because they actually have one of these time bubbles that they can go through, and that's what it actually is just like a
I don't
bubble
think
of.
it's a time bubble.
Oh no, not that.
No,
Okay.
no.
What?
Well, this big talk of bubbles, which I talk a lot about them. What that is once you learn the control of light, you start vectoring it. Your aerogels and your metamaterials aren't just letting it go willy nilly randomly. You're controlling it to the
Okay. Sorry. So I just
so you wrap it
conceptualized and
around the thing.
realized the implications of it all. That this is not like you don't have to bend space time or anything crazy like that for these
No,
sort of attacks to be working.
no.
It's all simply just metamaterial and utilizing the photons of the sun. That's all it
Yes,
is.
And
yes,
It's
principles of
essentially
buoyancy,
smoke
like
and mirrors. Smoke and
yes.
basic
mirrors.
principles of buoyancy, Newton's second law for how the acceleration and motion is. It's all basic concepts of physics. It's just been
Easy.
hidden from all of us since 1931. And it's such a shame because
I
it
would say
set
not
back
appreciated.
all of
I,
humanity.
yeah. Well, that'll
It
change.
really
I
has.
mean,
It kept us back 3 generations, right? At
Yeah,
least, at least.
yeah. My grandparents were lied to their entire life. My parents were lied to their entire life. I was lied to my entire life until I put in the research with my wonderful group Korea UFO, and we found all of these patents that proves that there is a hidden area of science, and it's not hidden anymore. So let's
yes,
go wild and use our best scientists to improve designs from a mediocre scientist like me.
Indeed, the derivative fifth force, and by the way, you're not a mediocre scientist at all, so don't discredit yourself like that. But yeah, that fifth force emergent element of interactions between any of your choice pick of the four fundamentals that we think we know are all present in the new physics model. And it does not
Agreed.
necessarily comply with our prior physics models. GR has part of it, SR has part of it, QM and QED have part of it. The thing is that none of these actually fulfill the entirety of this interaction because they fail to understand the nonlinearity simultaneously with the mass energy density. And it's something that still has yet to be completely flushed out in the physics terms.
yeah, it could be refined into 1,000 different ways.
And I agree with what WPG Enlightened for Truth 2 says, and it is time. Effectively, we're missing the temporal component, which is one easy way to summate everything that we're talking about here.
Yeah, it's time for the private sector to act on it. I mean, I don't know if these things are secrets or whatnot, or if they discovered it from flying saucers and kept it secret or any of that stuff. And I don't care. I mean, that's their job. We have ours out here in the private sector. And there's no excuse why this stuff can't be developed and optimized because it's nature. It's nothing. It's nothing magic. It's easy. It's simple. It's easy.
Right, and
It's
as Jeremy's got this diagram from one of your videos on your channel up here, would you mind
Yeah.
just explaining what you explained in your video? Right
Yeah.
here?
Well, what that
Fantastic
is,
diagram.
what that one is to take the human mind, and I did it for myself, so I put it out there for everybody else. That is the relative size of a photon going into an atom. Except those photons, those twirly things, they're about 1,000 times too small. In other words, what we don't see with our eyes or really think about enough is scale and size of time and space put together. And in other words, at the surface of a metamaterial, it's going to be that light there is going to be sucking in or pushing out. So
Right.
it's not going to have any friction mass or drag or whatever it is.
And this
Now
goes
that
back many
I
decades.
have to give Jeremy credit for this right now because um, he kind of focused me on this aspect a bit with all his talk of Mirabeau and his lasers and the whatever he calls it, whatever it is. It's keeping it away from the surface basically, and you build up a buffer, and then you start aiming those photons and wrapping them around the thing. Then you get a bubble of light, which is a thing that is barely affected by gravity. Now, what if you take a piece of mass in there? Is it stuck in the bubble? Is it less subject to gravity? I don't know, science. Big science. Look into it. Don't give me 13 freaking dimensions I don't need. When this is staring us right in the eye, you can basically, sorry about
Oh
that.
God, they're
Strange
so
thing, man. No,
lost.
you called
It
it.
needed to be
Actually,
said, Brian.
There was this big major issue, right? And I'm sure we probably remember it. Most of us that were watching the progress that, oh my goodness, decades ago, we discovered that it turns out an electron valence shell, a single electron can jump down one energy state by absorbing a photon that is thousands of times longer in wavelength than the actual distance that it moves. Because of why? An orthogonal field interaction and the equivalent energy momentum density caused by that little motion of the electron, which completely compensates the entirety of the electric field component for our absorbed photon. So now what we see is that a single valence jump or a tiny particle can emit a photon thousands of times larger than itself, but that also means inherently it must be capable of absorbing a photon thousands of times larger than
Yes.
itself.
Correcto mundo. And it comes in, it shrinks down 1,000 times, and it explodes out. But it's a very tiny thing. But it happens very quickly, and it can happen in very tiny spaces, and you can vector it.
Indeed,
Not
you
today,
can.
but it can be done. And you're on the right path here, Josh, and the rest of you.
Josh,
Yeah,
this is
polarization.
We're all on the right path now. This is free information for
This
everyone.
is
I'm
great.
just
Been
giving it a
around since
wider
Aristotle.
audience.
It's been around since Aristotle and is not yet in the common use, but it will be.
What have we
So,
learned in the
Brian-
last several thousand years?
So, Brian, basically what you're saying is it pulls it all in, and when it explodes out, it's just a lot like breathing naturally.
Well, that's one of my buzzwords is light breathing because there's air breathing. Jet. What are those things called? Ram jets.
Contraction and
Ram jet.
extract-
This is
yeah,
a ram
contraction
jet
and
for.
expanding, yeah.
Yeah.
This is a ram jet for light, which is everywhere and free.
If anyone wants the physics papers on this, to show to their professors and say, hey, could we do this? And anyone wants anything like that, please feel to reach out to me. I don't know if you want to share an email or
Can we
any.
get back first though to that presentation or idea of the energy unit on how it works to generate sort of before we?
Oh yeah, I
Yeah.
sent the image to Jeremy on Twitter. If you want to pull it up from your Twitter DMs.
Okay, give me 1 second.
Self-sufficiency is key for everyone out there. Because all you have to do is do it yourself, and you're good. So I know at least half the world wants to provide energy for themselves.
This document here.
Yeah, if you want to zoom in on that, I can answer any of the questions. It is a rough
Can you make
document.
that bigger at all? Can you just hit plus a couple times on your keyboard, or Control plus, or Command plus, or whatever it is?
No, it's a Mac.
It's not really zoom in,
Command plus, then I believe you should be able to increase or zoom in on the size. You could even pinch to zoom.
So essentially what we have
Not
is at the top left corner, we've got the sun. It's out there most of the days for most of the people. Below it in blue, I've shown a focusing lens, which is going to collect that sunlight and concentrate it down into concentrated photons directly below it. In black, you have 4 blades that are composed of the light reactive carbon nanotube aerogel. And as the light is only hitting one side of that windmill, essentially, it'll cause the blades on the left that are getting hit by the concentrated photons to rise up. Their density is going to be lower, so they will start spinning towards the top. As the blade hits the top, it enters a shaded area where, since it's not going to be exposed to photons, its energy density is going to lower. And that should impart a continual motion just with the power of the sun. In the center in green, you've got a standard generator shaft, which connects to a rotor stator, and there's your power.
Yeah, Brian's dead on right about the Crookes radiometer, and I love how this is a slap in the face to the idea of the photon rocket, which is usually the argument that other would-be physicists will give you to explain this.
Yeah, so you use a photon pump. Big deal. Like a submarine pumps water, as I've tweeted a million times. It's the same
Light
thing.
pumping instead of water pumping. Pumping
This
light.
isn't the same thing.
Joshua, what so this idea essentially can then be mass produced of like through 3D printing, I'm guessing is what you're going for?
Ultimately, yeah.
Scale them up either by making the device itself bigger, like a bigger focusing lens and bigger blades, turning a bigger generator shaft, or just make more of them. Like put one of these in every house. Just have it on the rooftop in Kenya, and suddenly villages that have had no power ever are making free power every day through the sun and cheap carbon nanotube fan blades, essentially.
Cheap and carbon nanotube don't usually go together. How are you going to mass produce this stuff?
It's going to get cheaper as we make more of them. So
yes, it'll scale.
As we work on the
actually
design,
scale
it'll
this up,
scale. It'll become cheaper. We're not using germanium like traditional solar panels, which that's
So
where
yeah,
the
you still have
cost
to use
of that
supercritical
comes from.
drying. So you would need a huge supercritical tank.
Yep, and you just keep reusing it to make more and more of these devices.
That's an expensive piece of equipment, though,
Yep.
and it can be slow.
One-time
We-
investment, though.
We have wasted $50 billion on this research over the last 5 years of taxpayer money. We have the proof, it's in the budgeting that went to DOE, Triad, and Lanel. If we put $50 billion towards this idea instead of towards recon drones feeding the sentient network, we'd have free power instead of being spied on all of the time.
I mean,
Who wouldn't vote for that?
it still isn't evident to me that this is yes, it's feasible. You could do it, but economically, I don't know if that's viable.
Yeah,
and
I think that now we've proved that it is feasible. We need to look into things like what the commercial viability is, what the best applications for. We need to have engineers take my stupid Photoshop design and actually make CAD models and stress models to show what the efficiency
product development. That's cool.
Absolutely.
Yeah, it needs to move from being totally hidden to being a product that is being developed.
They used to say the same thing about solar panels. Oh, we can have solar panels in Kenya, but like it's super expensive.
Yeah, so
this is the exact opposite, Michael, in the sense that the more that this technology gets out there and used, the more it also develops into your ultimate goal of what you're wanting to use it for, right? Like we want this technology that's been hidden to be able to be used by everyone, because it's like once superconductivity, once sort of things are out there and the knowledge is out there, you can't put it back into Pandora's box, and that's the key of it. And as soon as that happens, then you have the ingenuity that will inevitably lead to the efficiencies that make these sort of ideas practical and affordable and easily done, right? It's just
all right. I could see that maybe. Even so, supercritical drying is an expensive process, and that's why aerogel is not a commonly used material these days. Not necessarily because it's being hidden. It's expensive to produce.
Right. Well, it's like the first computer was expensive as F, and like it just
Bingo.
calculated two things.
Bingo.
But now everyone has like the most powerful thing in their hand that's almost quantum. It's just a matter of getting it up.
Well,
Excellent
it's the
example.
optimism, at least.
They've also recently made advances in the supercritical drying phase. It's not expensive anymore, like you say, because they're just using CO2 now. So it's reduced the cost of that
Quite a pressure
stage
tank.
considerably. You
You
do
need
need
quite
to
the pressure
make
tank.
you do need to create the pressure tank, as the document that I showed you earlier showed. They have a 1.4 meter sphere pressure tank that they can now produce aerogel composite bubbles in. So once you make that pressure tank to create the light reactive aerogel blades one time, you just reuse that pressure tank, and CO2 is now used as the supercritical
Right.
drying stage process. So
The
you're
one-time
using
investment.
carbon and CO2 and time instead of nuclear and germanium and oil that we need to fight for all over the world. And
And
But
industrially,
is
the
there
liquid
enough
people can
methane.
time,
take
though?
over.
Is there enough time? Because, like,
And it would also work in
supercritical
space.
drying.
Okay,
it's like-
hold on, everybody. So there's enough time. So the liquid methane process is fully recyclable industrially, which is how it's being used now to produce aerogels on a commercial application scale. So we can produce these things. We can recycle all of the predominant materials used to catalyze said substance, whatever we want to make it out of. We have not even gotten into the Platori genre
it still
of
takes like
morphine.
an hour to dry.
Well, days or weeks. But if
So?
you have lots of time and you can go slower, the slower you go, the better the quality, the better the lattice, the less likely you get cracks and
And that's therein
protrusions.
lies the challenge, because you want to
So
mass
here's
produce
a
stuff.
key of it. While it's drying, you have to put your charge through it that you want it at, and the specific frequency that you have that you pulse it with while it dries, and then you align all of the shells or electrons in one way.
If we
sort of
could
thing.
make a
Again, unrelated.
fluorine-based aerogel, imagine a fluorine-based aerogel, fluorine being the most electronegative element on the entire periodic table. We already know that it's actually the fluoride ion inside of NaCl that gets irradiated with gamma photons that slams the electrons out of position, and the entire lattice structure will change its composition, and it'll go from being a whitish table salt that you're used to putting on your food into an orangish substance, which when heated will release photons of equivalent wavelength before it down converts back into its native electron structure. So we know that we've changed the energy density of these materials, and the only thing we didn't do is actually rip the free charges that were released out of that structure. But we could effectively use the same technique and gamma radiation photons in order to generate brand new metamaterials with monopolar electrolyte-like charge. And this means instead of having to deal with the gravitational component, which is many times weaker than the electromagnetic coupling coefficient, we could directly catalyze these materials into a high state of scalar potential and use electromagnetism to propel these in a point where they would ignore basically the gravitational field because it's so insignificant by comparison.
Right. That's the goal. Ignore it.
That's not aerogel.
Cancel
though.
it. Mitigate.
That's like orbital rearrangement. That's not aerogel.
What I'm suggesting is that we actually try to generate an extremely high polarized scalar charge aerogel, something that had a fluoride ion instead. It's not entirely implausible. It's not been done yet, but that doesn't mean it can't be done.
I mean, I'm sure there's got to be a Teflon aerogel somewhere. That's probably a thing.
Well, most aerogels are super hydrophobic, so they are water Teflon.
Sort of. But, I mean, he's talking about literally having a fluorinated polymer-based thing, I think.
Yeah, something that in
Yeah, exactly.
air
Mike said.
also acts as a
But why?
naturally smooth material.
Because the electronegativity of that substance, its ability to release its electrons and allow them as free-flowing charges gives us the opportunity to extract them from the lattice structure, creating a net positive scalar potential inside the physical material, which means that we can apply an external changing potential in free space and use that to overcome the gravitational force. It would be a surface interaction, more so than a depth interaction, but the entire material would generate a field surrounding itself, which would not be subject to the Lenz's law or the conventional equal and opposite reaction forces, due to the fact that it's dealing directly with the refractive index, and that's where we are generating our forces, is a change in the gradient of the refractive index, not a direct equal and opposite reaction force.
Also, what was that about the gammas?
The gammas can actually free the electrons out of the lattice structure from the fluorine ions, or from the fluorine atoms, turning them into fluorine ions, positively charged. And then we can rip those free electrons out of the lattice structure. Take a look at the search term irradiated salt.
I mean, but at least for fluorine, if you're talking about removing electrons, all you really need is ultraviolet light.
That won't penetrate the whole depth, though.
I mean, maybe if you have an aerogel, it would.
Once the electrons and the outer layers end up getting bombarded by gammas and their electrons are freed, then the gammas will actually penetrate into the deeper layers until they have passed their way completely through the entire mass of the material. I've actually got a little sample sitting between two fairly hot ore samples right now, and I'll leave it there for about a week, attempting to do precisely this with sodium chloride, but then I'll be moving on to a variety of other salts and then eventually into polymers.
Oh, okay. So you think that it's some ionized form and it's Ormsers? No, when you hit the salt with gammas, it becomes metamixed. That's all that's going on. That's what the orange color is. If you heated the salt up, it would turn into normal salt again. The metamictization is it's interesting, actually.
Indeed,
Yeah,
the fascinating part is that it generates light.
You're annealing the crystal structure and you're removing the crystal defects caused by the radiation.
Right, but here's the thing. You see how it's going to generate light when he heats it up? So that is, if it's generating or releasing light, we would call that a trapped light state. And trapped light is something that we've been seeking for a long, long time. And here's a mechanism to achieve it very easily.
That's interesting, actually. But the light there is a lot less than the gamma that was used to produce that state originally. Indeed,
that's true. But what do we care if that gamma source is going to continue to produce radiation for tens to hundreds of thousands of years? Like, why do we care what the losses are?
Because that's not what's happening there. It's not producing light over tens of thousands of years. It's just producing light when you heat it up.
Well, it's releasing the light that it absorbed as a result of electron displacement from gamma ray absorption.
Yeah, the total energy density of the storage mechanism is probably small.
Right, but how do you think that affects the physical nature of the material and the way it responds inertially to an acceleration force?
Well, I have no idea.
That's specifically what I'm poking at here. The way it responds to an acceleration force is going to be modified as a result of the charge displacement.
Well, you might want to play around using zircons then, because radiation in the Earth makes zircons metamict.
That's a genius idea. What if I take that strontium zirconate and make a salt out of it?
No, I mean you just get zircons, like zirconium titanate, from the Earth, and they're already metamict because they've been sitting in the Earth getting hit by radiation for long periods of time. That's why zircons are brown mostly, except the
zirconium titanate. I will put that on my list to quickly acquire.
Zircons, just zircon crystals. There's tons of people that sell them. You want a brown one.
Well, I've got strontium zirconate powder, which is what I was going to use.
I'm actually curious to see if you heat it up, does it glow? Because it might.
I will run that experiment for you.
Yeah, that one there. Yeah, it's metamict because of radiation damage, because of the small amounts of thorium and uranium in the areas where it's produced. Sometimes it's from other impurities, chemically speaking. But yeah, zircon crystals frequently go metamict, like that salt. There's a couple other things that there's like radiation damaged quartz. If you see like a very bright blue quartz, it's typically radiation damage. It's like look up radiation damaged quartz, Jeremy.
Well, thanks for the search term damage, though. I would have to disagree with the
metamictization.
way they contextualize that.
Metamictization is the search term you want.
Metamictization?
Yeah, look, see, there's like blue. Oh no, that's a piece of tanzanite.
Could you
Of
spell it?
course. Metamictization. I'll put it in the chat here.
MECH? META,
Yeah. There you go.
METAMICT.
MECT. Ah, I've never heard of that. Thank you for telling us.
Yeah, that's what's happening in that salt you got there. Let's see if I can find it, because there was a bright blue piece of quartz that let's see. Oh yeah, no, that's
If you could
gold
find
coated.
it, place it in the private chat. This has been a fascinating discussion. I want to end it before the 2 hour mark because I don't want it to get flagged for the algorithms. YouTube doesn't like us going over 2 hours. But I want a lot of people to see this, and I'm going to forward your contact info, Josh, to some other people to try to get you on some bigger platforms.
If you're okay, maybe hanging out for 15, 20 minutes afterwards for some private questions if the guys want to ask, if that's all right, Joshua?
Yeah, I can, and I'm also willing to come back on here anytime. As I mentioned earlier,
we're going to hold you to that. There's no doubt about it.
Oh, this
No
is
pressure.
catastrophic.
I'm retired, so
pressure.
feel free to use my time up, and I'm willing to answer any questions on this subject because I think
The
more
after
people
parties
need
are
to
the
know.
best. They're so
We
good.
appreciate it, and I look forward to getting to know you much more and much better in the next one. And after this one ends, thank you, Jeremy, for putting this together. Thank you, guys. And this is what needs to happen. This is what's so important, is just the coming together and the putting out and open sourcing of this knowledge and this technology and disclosure through technology, that those willing to use it and put it to use themselves for good use can do so and make the world a better place.
Yep, nothing catastrophic, just a bright future.
Nice to meet you, Josh.
Thank you. Nice to meet all of you too.
Awesome. Yeah, I'm going to wrap it up here, guys, and I'll be sending out that link to channel members for the after party link if people want to join and hang out and ask some extra questions. So thank you all for watching there in the live audience, and I'm glad. Respect to Josh for coming on here and sharing this excellent, mind-blowing, catastrophic disclosure information with us here today.
Yeah, before we head out, can we all get an applause for Jeremy for putting together this amazing freaking panel?
Jeremy and Joshua.
Absolutely.
To 2024 being the year that we all take flight.
The year of truth.
Different type of propulsion.
The year of truth. I like that. Let's get it released.
Let's get it. We're gonna build one of these things, and I'm gonna fly it over the White House. Oh, maybe not.
5.5 meters. If we get to 5.5 meters, we can put a human in one.
Yes.
Or even just to surf temporarily, I'd be okay with that.
Sounds good.
All right, let's do this. Thank you, guys, and take care. Bernie, if you want to play that awesome outro, go ahead.
It's a long outro, so don't go away while it's playing.
All right. We won't play all of them.